Hello, Algebra Honors. How's everybody doing? We have another lesson today. Yay, lesson 5, Introduction to Inequalities. And I just stuck a 1 in there, and I don't want to do that. I'll get that out of there. Hold on. There we go. Okay, let's start the lesson. So, you've done these. There is some stuff that, I know, you've done them all. You've done some solving for inequalities as well. We're gonna do just basic understanding what inequalities are on the first part, and then you're gonna do some solving on inequalities, and we're gonna do something new. So this one's got a little bit of meat to it as well, okay? And I'm going to, it is 3 pages long, but the back page I'm only gonna do about half of them, and I'm gonna expect you guys to do the other half, and then we're gonna do a little check when you get back in, because I'm gonna check your notes, make sure everything's up to date when I see you next. Okay, so be aware of that, please. Okay, so symbols for inequalities. If you were in class with me, I would have you shout out what that means. This one means, and this is a less than symbol. This one is a greater than symbol. This one is a less than or equal to symbol. And that last one is a greater than or equal to symbol. Now, the equals to means, right, it can be equivalent to as well, okay? So when I say x is less than 5, that means that those are all the values for x that are under 5. So 4, 3, 2, 1, 0, right? For this one, x is greater than 5 means that is any number above 5, 6, 7, 8, 9, 10, right? Those two do not include the number 5, right? Now, if I do this with an equals to, like that's an equals to symbol, that means that it can include 5 for both of these. Now, did you notice that I was giving you a lot of answers here? So like going back to that first one here. X is less than 5. It's not just one number, right? It can be 4, it can be 3, it can be 2, it can be 1, it can be 0. So a solution set for an inequality has infinite solutions. I actually just gave you the integers, right? So if I say x is less than 5, couldn't it be 4.9 or 4.99999 or 4.99999, right? It can be any of those. So we have infinite solutions when we do solution sets. Unlike equations, where typically the ones that we saw before, we either have one solution, no solution, or we do have all real sometimes, right? Which is, again, that infinite solution set. All right, so when we're going to test these to start with, just to make sure that you have these. So it says testing possible solutions in an inequality. In each number following the inequality, a solution, let me try it again. Is each number following the inequality a solution of the given inequality? This is Reese's challenge with that reading today. Okay, so I want to see if -4 is greater than or equal to 0. Okay, so what do you know about numbers? Right? Is -4 a larger number than 0? We're going to say a big fat no. Right? Okay, so you're going to try it with these. Plug 5 in for that. Plug -2 in for that. Go. Go, 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 go. Now, if I were you, I would have converted that fraction to a decimal, and it was 5.3 repeating, and you would say yes. 5 is less than, right? 5 is less than 5.3. There's another way you could read this, which I've had kids do, because I don't know, there's going to be some things coming up that you might want to be able to read it the other way. And this is 5.3 is a greater number, right? Because remember the alligator eats the bigger number. So if I read it from the right to the left, I could say 5.3 is greater than 5. Okay? And then in this one, -5, is that less than -2? And you should absolutely say yes. Remember, it can be in a mirrored scenario. I could say -2 is greater than -5. That means the same thing, right? So notice how they're mirrored. And again, that alligator is eating the larger number, right? So let me say this one, -5 is less than -2. Or we could say it in this direction, -2 is greater than -5. They both are yes. They both are go. Okay, so you got to remember your negative signs. And we're going to do a couple number lines on the back so you'll see. Okay, so it says, which of the following are in a solution set for the inequality n parentheses n minus 3 is less than 54? So this, if you were to go and actually try and solve this, like we're going to do on the back page, you would not be able to do this yet. Not yet, but you're going to soon. This year, I see an n squared. So instead of, because n squared you can't solve for yet. That was my point. So instead of doing that, we're actually going to make n equal 9 here. And n equal -3. And n equal 10. And we're going to plug it in and try it. Okay? Do your math. Go. Try that. Let me know if these are yeses or nos. Is that a number in the solution set? Does it satisfy that inequality? That's what you got to ask yourself. Okay? Do the math. You should have gotten 54 is less than 54. And that does not satisfy. That's a no. Because we don't say it's equal to. We say that this left side's got to be less than 54. And that isn't. When 9 is plugged in for n, it doesn't work. Okay? So pause, take a minute, and try B and C. And then when you come back, you'll see my answers. Okay? So when you plugged them in, you should have gotten that. So make sure that your signs are right when you're plugging all this in. And that should be your answer. Okay? All right, go to the next slide. This is where some new stuff comes up. So I did say that a lot of this is review, like you've done it before, but there is some new stuff, and this is called set notation. All right, so since there are infinite number of numbers in the solution set for an inequality, we often graph the solution set on a number line, and then we use something called use interval notation or set notation. So set notation is what you've been using. Like these are set notation, like these up here that I actually gave you. Those are all set notation. I don't want to leave that there. So those are something that you're familiar with. The interval notation is new. So let's read this. So set notation is where you fill in with inequalities using inequality symbols. You've got that. The interval notation is another way of describing the set of answers by using brackets, parentheses, commas, and infinity symbols instead of the variable and the inequality symbol. So in interval notation, you don't have X's. Like we'll represent it something different. In interval notation is a biggie. Like we do it a ton. In geometry, they do it. They have it in geometry, and we do it a lot in E2. All right, so the symbols that you're going to see are parentheses or brackets. Now, if a number is included, you'll understand when I do this, it is a bracket. So if it's included, it is a bracket. If it is a parenthesis, it is not included. Okay? So let's go through this. So if I say to you, graph each of the following and express your answer using interval notation. Remember, these are all set notation, right? We've done this before. Those are set notations. I want you to graph it. I don't want a big number line, by the way. It's got a ton of numbers. I don't. We're not going to waste our time with that. I will tell you though that make sure that you like understand that numbers on each side. Maybe put like 3 numbers so that you're comfortable doing that number line again. So if I'm going to the right, that means I'm increasing the values. So the next higher number is -2. And then if I go to the left, the next lower number is -4. Okay. Now, if you remember, let me go back here. Let's go back to that other page. These are, when we graph on a number line, these are open circles, and these are closed. Closed means I include them, right? So that means in this one that I have, it says -3 is less than x. Now, I'm a fan where I prefer to read it from x. So I'm going to read it from right to left, which when I read it from the right, I go x is greater than -3. Okay, so you can read it from the left to the right. -3 is less than x, or x is going to be greater than -3. So I know right away that I'm going to the right. Okay, and I'm going to have it open at -3, which means I can't include -3. So I'm going to go in this direction, just like that. Okay, so let's get them all down on a graph, and then we'll do the interval notations. We'll do the interval notations all together. So take a minute. I'm going to pop them up here. You're going to stop the video again, and I want you to try these. Okay, take a minute and try. Okay, so hopefully when you unpaused, you watched me do all that, because again, I can't pause mine. But if I could pause mine and put it on and then unpause it, that'd be great, but it doesn't work that way. Okay, yours should match mine right now. Okay, so now we have to do this interval notation stuff. Okay, so now this is very important to pay attention to, right? Because we're going to do a lot of this, like I said. You're going to start with the lowest number. So in this case here, -3, I'm going to do number 1. -3 is the lowest number, and I'm going to write it. And I'm going to put a comma there. And what it's saying is that this -3, and it goes to the right, it goes forever. So I'm going to do an infinity sign. So meaning that it starts at -3 and it just goes forever. All right, now parentheses versus brackets, okay? Now, parentheses means it does not include. Remember, we read this up here, and it says we always use parentheses to enclose infinities. So I always, around an infinity, whether it be negative or positive, is going to put a parenthesis. Okay? If it includes a number, so -3 is not included, then we would use a bracket. But we don't need to. So we're going to do a parenthesis around there. And that is your interval notation. So anytime you see that, if I look at that right now, I go, oh, that means it's going to have a number from -3, but not including -3, to forever. I always read left to right, okay? And remember that left to right. Okay, so I'm going to go to 2. And going to the left, well, does it ever stop? When I go to the left on that number line, it never stops. That is a negative infinity symbol. Remember, all infinities, parentheses. Comma, reading from left to right, lowest to highest. The highest number it can go to is 5. So I'm going to put a 5 there, and I'm going to put a bracket. Okay? What do you think? Okay, try 3. All right, so 3, lowest number can be. -9. It includes -9, so I'm going to put a bracket around it. 2, where does it end? It doesn't end. It goes to infinity. So there's the infinity, and we put a parenthesis around it because that's the symbolic notation we use for infinities. All right, try 4. See what you can do. Lowest to highest. Always lowest to highest. Left to right. Did you get that when you did it? Negative infinity to negative 11. Yes? Hopefully good. All right, so now I'm giving it to you already on a number line, and you got to give me the set notation and the interval notation. So this is where you're going to take a minute, and you're going to do it. You're going to put on pause again. This is where you really got to try it. Don't, like, I'm not even going to explain it. I'm just going to put answers up here. So put me on pause, try it, and then take me off the pause, and you'll see me right now. Okay? Go. Okay. Hopefully you've taken me off a pause. You watched me write them all down, which is boring, 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 but you got that. And I noticed in the set notation I put little squigglies. You don't have to, but you can because that's part of that set notation piece. And you've gotten brackets, parentheses in the right spots, so make sure that all that's good. And you absolutely, there's no negotiating. On the intervals, in interval notation, you can't flip them. You can't have the infinity sign first and then the negative 3. This is always lowest to highest. You can, however, for the set notation, you could have these different. Like you can have these flipped. I wish I could go. Let's do this. You can have negative 3 is less than or equal to x. Like it could be that way. Or 5 is greater than or equal to x. Or 19 is less than x. Like I always write it from the x. I don't know why, I just always have. But if you had them flipped, that's fine. Interval notation, not negotiable. You can't flip them. Okay? All right. Keep going. You got a little bit more to do. I am going to do, let me see, which ones am I going to do? I'm going to do number 1. And then I'm going to do number 1. I'm going to do number 2. And I'm going to do number 3. And I'm going to just have you do 4, 5, and 6. Okay, so I'm going to do the first 3 of these, and then your job after we're done with this video is to do 4, 5, and 6. Oh, and 7. 4, 5, 6, and 7. And I know 7 is going to be a little bit tricky, so it's definitely one that we're going to have to talk about when we get into class. Okay? All right, here we go. So now the ones that I gave you before were already solved. They were inequalities that already had x by itself. These down below, you can see, don't have the variable by itself. So we're going to have to solve inequalities. And there's a golden rule with this. When you multiply or divide by a negative, you have to change the inequality sign. Okay? And I typically do a warm-up to explain this, so I probably am gonna slip that in when you come back to understand why this even is the case. All right, so we're gonna solve and graph the solution set on a number line and write the solutions in the specified notation. So if I ask for set and interval, I want you to do that. If I only, like some of them down here, I only ask for interval, I only ask for set, you got to be able to go back and forth between them. All right, so depending on what it's asking for, the first 2 are set and interval, and then I depending on the problem, I changed up. All right, so we got to solve first. So the first thing that we're going to do is I'm going to get the x's to one side. Don't be afraid of the negatives. Okay. And then I'm going to divide. Now look what I'm doing. I'm dividing by a negative value. So what did I say about the golden rule? When you multiply or divide by a negative, you change the inequality sign. So that less than sign now becomes a greater than. And we have that. X is greater than 9. So I'm going to put it on my number line. Probably do one less, one greater. Open circle, because it does not include 9. And then X is going to be any greater than greater. So there it is. Set notation. All right, set notation is really already there. X is greater than 9. You can put it in little squigglies. Interval notation is the new one. Lowest value is 9. To greatest, well, it goes forever. Infinity. Parenthesis around both because it doesn't include the number 9. That's it. Okay. All right, let's try 2. I'm going to get the x's to one side and the y's. Okay. Now, I didn't say this in one. This is just like solving equations. Same thing, right? You're going to get all the x's to one side, all the constants to the other side. Doesn't matter which order you do it in, as long as it's right. But remember, when you multiply or divide, you always change the inequality sign symbol. So I'm going to minus the 12 here because I want to get the constants together. And I'm trying to solve for x, so I'm going to keep that separate. So I got negative 20 is greater than negative 5x, okay? Got to get the x by itself, going to divide by negative 5. When I do that, negative 20 divided by negative 5 is 4. And oh, wait a minute, I divided by a negative, which means that symbol is going to flip. And now it's x is greater than or equal to 4. Okay, so 4 is my magic number that I got to write on here. Right? It's going to include the number 4. And remember, it's x is greater than, so I'm going to go in this direction where the numbers are greater. Okay, I've already got my symbol notation, or my set notation. All right, then I've got to do my interval. My interval is going to be 4 with a bracket, because it includes 4, to infinity. Okay? And that's it. There's nothing fancy about these. Like, far as the solving goes, you just got to remember that golden rule, right? That's going to be your key. Let's try M. So with M, I'm going to get the m's to one side, or 3. I said M. Let's try 3. We're going to get m's to one side and the constants to the other. Okay, so do that. You get to pick which way you want to set the m's. I'm gonna make it so that we don't have a negative this time. So that means I'm going to bring the m to the right, right? Because the 3m is larger, so it means that we won't have a negative. And at the same time, just so you know, I'm going to subtract that 4. I'm just doing 2 steps in one. Hopefully that doesn't mess you up. Are you okay with that? I did the constants, I moved to the left, and the m's I moved to the right. And now I'm going to divide by 2. And I got negative 3 is greater than or equal to m. All right, so here's my negative 3. My negative 3 is the greater number, right? So, and it includes negative 3 because there's an equal sign underneath, right? There's an equal symbol. And again, I read it from the variable, so m is going to be less than. So that means I'm going to go in this direction. Okay? In set notation, I don't even make you do interval for this one, so you already got this one in the bag. There is your set notation. And that's it. So I do want you to try the next 4. It has to be done. Plus, you're going to do your homework for this, okay? The homework is in your homework packet, and it's lesson 5 homework. All right? And any questions you have, we're going to be seeing each other next after this video. So you compile your questions, and I'll go over some stuff with you. Okay? All right. Take care.